Lewis structures. Lewis structures are a skeletal representation of what a compound will look like in a 3D format. That will be your next step in this process, is to determine what its 3D shape is. So let's first focus on how to draw the skeletal structure. Remember, you need to count the valence electrons. That means the number of outer electrons. Those are the ones that are involved in bonding. Then you need to draw a skeletal structure. Skeletal structure is talking about having a central atom and drawing the other atoms surrounding it. Make sure you bond these outer atoms to the central atom, and every time you bond it uses 2 electrons. And the rule is you have to make sure that all of the atoms have 8 electrons except for hydrogen, which needs only 2. So let's take a look at this compound, fluorine. Determining the number of valence electrons, the shortcut method is to look at the group number that it is on the periodic table. So you should have a periodic table in front of you. You'll notice that fluorine is in group 7A. That means then it has 7 outer electrons. However, notice that there's 2 of them here in the compound, so each one contributes 7 valences. Multiply that by 2 of the fluorines in there, and you'll get a total of 14 valence electrons. That means that my compound needs to use all 14 electrons. I can't invent any more electrons, and I cannot leave any on the table. So the first thing I'm going to do then is draw the skeletal structure. I have 2 fluorines here. Next I'm going to do is I'm going to bond them. Here are the 2 electrons that are going to be used for bonding. When I do that, I need to make sure that I minus it from the total valence electrons. So I know that I have 12 electrons left that I have to use to make sure that everybody has the use of 8 electrons. Now I've drawn the 2 dots here to demonstrate the bonding between the fluorine atoms here, but you can also draw a straight line, and the straight line still represents 2 electrons in here. I will always draw straight lines for bonding. Alright, here, so let's take a look at using up the rest of these 12 electrons here. When you draw the electrons around your atom, make sure you always put them in a pair. Remember, in electron configurations, electrons occur in pairs when they bond up. So I'm going to put 2 on top. That's 2, 4, 6. I've used 6 up, so when I minus off the 6 down here, I have 6 electrons left to be using. Now this fluorine atom has the use of 8 electrons. That's 2, 4, 6. Remember, that represents 8. I'm going to use up my other 6 electrons over here on this one. And it just so happens to work out absolutely perfect. Notice that I'm still doing my bookkeeping every time I use up my electrons. And I go back and I always check to make sure that all of these have the use of 8 electrons. And when you count these, you'll notice that this fluorine has the use of 8 electrons, and when you count up these, this has the use of 8 electrons. Hydrofluoric acid. Again, you want to determine the number of valence electrons. Hydrogen belongs to group 1A, so it has 1 outer electron. There's 1 of it, so it contributes 1 valence electron to drawing the Lewis structure. Fluorine contributes 7 electrons. So that means I have 8 electrons total that I need to use to make everybody happy. Draw the skeletal structure between H and F. The next thing you're going to do is you're going to bond these together. Again, I use the straight bond. And when I do that, remember that that bonding represents 2 electrons. Doing the bookkeeping, I realize I only have 6 remaining electrons out of the 8 valences total for this compound to give everybody 8 electrons. So let's determine this by starting to draw our 6 electrons. Now some students will start adding over here. They'll give 2, 4, and 6 here to hydrofluoric acid. But even though I would use up all of the remaining 6, notice that hydrogen has the use of 8 electrons, which goes against the rule that hydrogen only needs 2 electrons to be happy. Fluorine, on the other hand, only has the use of 2, so that is not a correct representation of that drawing. Let's try it again. I'm going to draw my 6 electrons. Hydrogen is already done, so I need to focus on drawing my 6 electrons around fluorine because my goal is to give him a total of 8 electrons. When I count again how many electrons are around fluorine, I'll count 2, 4, 6, 8. 8 electrons around him, 2 around hydrogen, and it's done. But don't forget to make sure you minus off those 6 electrons you drew to show to yourself that you have 0 electrons left. Eventually you're going to be taking these Lewis structures and determining a 3D shape of it. This has a name, but I wanted to introduce that this 2D molecule on your screen really does have angles to it. Notice this green ball here represents fluorine, and this is the bond attached to hydrogen. And then these are the pairs of electrons that surround fluorine to give it 8. Water. Determining the valence electrons. Remember to look up on the periodic table, see what group numbers these belong into, and multiply by how many you have of each. You'll see then I have a total of 8 valence electrons. Draw your central atom. Again, you can tell what your central atom is because I'll either have it underlined in the compound, and you'll see that in your Lewis structure lab. And also a clue to you is that when there is multiples of the same atom, they are usually the ones that surround the central atom. So oxygen is our central atom, all surrounded by hydrogen, and let's begin using up some of these electrons so that everybody will have 8 except for hydrogen. Alright, so here I do the bonding electrons. I draw my straight line. Each of those represents 2. So that means I've used up 4 electrons for bonding. So I have 4 electrons left to make everybody happy. Hydrogen is already happy because it has the use of 2 electrons. So those 4 remaining electrons are going to go in hydrogen. So I'm going to put 2 electrons paired on top and 2 paired on the bottom. I will have used up a total of 4, and doing my math, I have 0 electrons left. That is the Lewis structure of water. Now some students will draw the Lewis structure of water like this, and this is incorrect because the rule is a hydrogen only needs to have 2 electrons, and this middle hydrogen has the use of 4 electrons. So that would be a reason why this would not be a good Lewis structure. Another reason why it would not be a good Lewis structure is count how many valence electrons are being used in this compound. I have 2, 4, 6, 8, 10 electrons. Remember, we only have the use of 8. Therefore, whoever drew this invented 2 extra electrons, and that would be a reason why to exclude this as a Lewis structure when you're learning how to draw it. Here is the Vesper, or the 3D representation of water. Oxygen's in the middle. It is connected to the 2 hydrogens. The 2 pairs of electrons that surrounded oxygen are on the outside there. Ammonia, again, belongs to group 5A. When you do calculate how many there are, it's very important again to multiply how many appear in your compound. Notice that I'm multiplying hydrogen's valence electrons by 3 because there's 3 in ammonia. Again, I have 8 to use. Nitrogen's my central atom. I'm surrounded by the hydrogens. I'm going to draw my bonding electrons with the straight. If you want to use the dots, that's fine. I like it this way. I've used 2, 4, 6 already. I've used them up pretty fast, and I only have 2 left. Notice hydrogen is done again because they only need 2, so the remaining 2 will go on top of my nitrogen. And I make sure again to always minus those off just so that I can see I have 0 electrons left. Nitrogen has the use of 8. Don't ever skip that step of going back to make sure, count and recount that everybody has their number of electrons. The other major mistake is people will invent extra electrons or they will not use all of them up. So bookkeeping is very important. Again, the 3D representation of ammonia, here's nitrogen in the middle with the 3 hydrogens and the lone pair of electrons on nitrogen. This does have a name to it, which you will learn very soon. Sulfate with a -2 charge. When you add up the valence electrons, the thing that is different about this one is that it has a charge. The reason why it has a charge is it has an excess amount of electrons. The sulfate ion. That's where it gets its -2 charge. You need to add that into your total valence electrons. When you add them up, then I'll have 32 valence electrons for this compound. Draw your structure, connect them, bonding them to each of the oxygens. I have used up 8 electrons. I would have taken the time to minus out my 8 bonding electrons. Sorry, that's an 8, leaving me with 24. Distributing them around the outer atoms first to make sure that everybody has 8 electrons, and when you do that, you'll discover that you have used up all of them. But this is not finished, because this would not be this shape of the molecule or the Lewis structure unless it had a -2 charge. So my finished structure on this is to make sure I put square brackets around here and to show that this exists because it has a -2 charge.